All right, welcome everyone. We have our review for geometry for our upcoming area test. I highly recommend having your formula sheet ready to go and that you understand how to use it. I don't have one in front of me here, mainly because I know my formulas, and you could know them too. Not a big deal. Let's start going through them. We're going through the odds of the homework that is going to be due on test day. That is Thursday. So starting off with the very first problem, because we're doing the odds, so just going to underline the ones we're doing here. It says a triangle with length 8 and a height 12. Really, it should have said base length here. I don't really know why it just said length itself. Really should have said base length, but you're just finding the area of this thing. And our area of a triangle is 1/2 times the base times the height. Just make sure you actually include your units when you go ahead and multiply that through. So that's going to go ahead and be 48, and we're going to have, say, centimeters squared. Easy peasy, really not much to that problem. Same thing with letter C, a square with side length 17. Well, 17 squared, hence the word square. That is what that means right there. Again, not that big of a deal. What is this guy going to be? It's a good one to have memorized. It ends up being 289. And then we have to make sure we include our units. Inches squared. Wonderful. Parallelogram, base 24, height 3. Formula for area of a parallelogram. These are like the easiest questions ever. You just multiply the base times the height. There's your formula right there. That's going to be 72 feet squared. Finally, a trapezoid with bases here. A little tiny bit more work. We got 1/2 multiplied by 7 plus 14 multiplied by 10. Please note the easiest way to do a question like this is, if possible, you want to go ahead and make sure you can divide by 2 right away. So I can do the 1/2 times the 10 first, and that's going to go ahead and give me 5 multiplied by 7 plus 14 is 21. Overall area, 105 meters squared. Easiest first page of all time, and honestly, this is like the first page of the test. So if you're able to do this one, you've already got 1/3 of the test knocked out. Let's go to the next page. Again, I'm doing every other question, so just want to circle the ones I gotta do. We got the A, C, E. I said in class to skip G. One of the classes I said to skip I. I'm sorry I didn't say that in the first class, guys. You can skip that one here. And this one says here, find the height. It really means find base 1 is really what that should have said there. And then after that, we have to go ahead and we're doing every other question. So we have this guy right here, and then we're skipping this one, and we're going on to this guy right here. Let's go through them. So, area of the parallelogram. We basically just did this problem. 8 multiplied by 6, base times height. You got to make sure it's perpendicular, but it is this time. So 8 times 6 is 48 meters squared. So easy. Finally, we have one where it requires a little bit more thinking. The height of the triangle is 90 feet squared. So, the height of the triangle into the area is 90 feet squared. So we're going to say 90, and we're going to set that equal to our area formula, which is 1/2 multiplied by the base, which in this case is 6. Please note the base is not the one on the bottom, but the one that is perpendicular to the height. 1/2 times 6 is 3, so if you really want to write that, you could write 3 there. 90 divided by 3, because we're dividing both sides of the equation by 3, gives you 30 feet is the answer for our height there. Make sure you include the right units. Notice how this one was squared because I was finding an area. This one I'm finding a length, so I just put the feet. Here, area of the kite. Again, formula. Got to have it down. 1/2 multiplied by diagonal 1 times diagonal 2. You multiply this through, you will actually also get 30. But we're talking about 30 kilometers squared here for an area. We had kilometers as our unit. Skipping those next two, we're going right to this trapezoid one here. Again, nice and simple once you know how to do it. So this guy's got an 84. Our area equal to the formula, 1/2. And then we have our base 1, which we don't know, plus base 2 multiplied by 7. Couple of options to solve this problem. My personal favorite is, again, just to start off by multiplying the height times that 1/2. It's not evenly divisible by this time, but we can still do it. So we're going to go ahead and get 84 is equivalent to 1/2 times 7 is 3.5 multiplied by B1 plus 15. After that, we want to go ahead and divide both sides of the equation by 3.5. So we can do 84 divided by 3.5. Feel free to use a calculator, but it does end up being, what is it, 12 times 2 is 24. Base 1 plus 15. Subtract 15 on both sides, and we're going to get 9, and it looks like we're in inches for this guy. Please note, if you're worried about your algebra skills, you could always plug that 9 back in, see if you got the right answer. 9 plus 15 is 24. 24 divided by 2 is 12. 12 times 7 is 84. Boom. Easy peasy. Now I get to take a little tiny break for our first shout out of the day request. Shout out was requested, and this was a shout out requested. It was a shout out to my homeboys, Noah and Owen. Yeah, you guys are awesome. Usually not working too hard, but I do get the work done eventually, and I do appreciate that, so thanks for getting that work done. Let's find the area of this next one. Area of the trapezoid is 385. So we got 385 is equivalent to 1/2 times base 1 plus base 2. And, we don't have that entire base. We only got, like, you know, a part of that base. That's kind of an issue here. So we got to get through it. So we have only part of this base. We only got that 23 right there. But we are given some other information. We are given that if this guy is 23, this guy is 50. Well, what are we going to do? What are we going to call this guy? We need to find the height. Does it give us enough information? It wants this length here. It wants that length up there, that length x. Ooh, I didn't read the whole question. HJKL, which is this trapezoid right here, it does give us enough information to find that height right away. It actually gave us both the bases. It didn't give us this entire length. I just didn't fully read the question. That's my bad. So we had 32 over 23. And you see, guys, even I have to think about problems sometimes. And that is totally okay to have to think and stop. You know, I don't know how to do this. Think it through. Multiplied by that height. So this one, I can't do that trick that I wanted to do originally, where I did the 1/2 times the height, because we don't know the height this time. So instead, I would add these two things up first. We're going to get 385 is equivalent to, and now 1/2 times those two things added together. So 32 and 23, that's going to be 55. 55 divided by 2, that's going to be a nice 27.5 H. Not too bad. After that, I'm going to go ahead and divide both sides by 27.5. And I'm pretty good at math, but I'm going to go ahead and go for a calculator on this guy. So we got 385 divided by 27.5. Boom. That gives you a nice little 14 for that height. But that is not the end of the question. So the question asks for this letter x right here, LM to the nearest tenth. So we figured out that this was 14. Now we finally have to use trig, just like we were practicing in class. If you're forgetting the sine, cosine, which one's opposite, hypotenuse, all that kind of thing, don't forget you have that formula sheet, and the formula sheet does give you that information. So what are we going to do here? We have 40 degrees right here. We also have 50 if we needed it. You can either use 50 or 40. I'm using 40 because that was given to us in the question. So I'm going to say the sine of 40 degrees is equivalent to the opposite over the hypotenuse. To solve that equation, we flip-flop the x and the sine of 40. In this one, we absolutely have to use a calculator. Doing this by hand is basically not possible at this stage. You need some calculus to do that by hand, and that is not even what I would want to do by hand ever myself. Don't forget, your calculator must be in degree mode, so don't forget to do that. So mode, degree, double check that. If it's not in the degree mode, it will give you the incorrect answer. So you got that 14 divided by sine of 40, and it says round to the nearest tenth, so make sure you round correctly. We got 21.8 and units, millimeters. It's a length. Easy enough. Moving on to that next question. These ones I haven't even read yet, so we're gonna have an adventure here. The length of a rectangular pool is 2 feet less than twice its width. So let's draw a little picture for ourselves. So the length is 2 feet less than twice the width. So here's our width. Our length is 2 feet less than twice the width. There we go. And it says here, if the area of the pool is 264 feet squared, what are the dimensions of this pool? Please note, I'll solve this question just so you guys can see it, especially because you might need it for your homework, but it will not be this difficult on the quiz because this one requires some factoring. Let me explain. The area has got to be 264 is going to be equivalent to, and then we have W multiplied by 2W minus 2. After that, we're going to go ahead and say 264, and we're going to distribute that W to both. Not a required step, but a very, very good step here is noticing both sides are divisible by 2. Because both sides are divisible by 2, I'm going to do so immediately, dividing by 2. Divided every single term by 2 there. After this, I'm going to jump up here now. I'm going to make one side equal 0 by taking that 132 and subtracting over. And now we have to factor or use the quadratic formula, one of the two. I prefer factoring because I think it's easier. It turns out that 11 times 12 is 132. So we're going to do W minus 12 multiplied by W plus 11. And again, that negative 12 plus 11 adds to that negative 1 there. Again, we're not going to have to factor on the test, but it is definitely good review, very useful for next year. So W is either equal to 12 or negative 11, but this is nonsense. It can't possibly be a negative number, so we're going to get W equals 12. However, just because W is 12 doesn't mean we're done with the question. It wants the dimension, so it also wants the length. The length is 2 less than twice the width, so 2 less than 24 is 22. Don't forget your units. Feet here and feet there. Boom. Let's continue on. Jamie is cutting out 32 right triangles from fabric from her quilt. 32 right triangles? That is a lot of right triangles. Whew! The shortest side of each triangle is 2 inches. The longest side is 5 inches. How much fabric will she use to cut out all of the triangles? Well, it says right triangles. So basically, the longest side of a right triangle is always the hypotenuse. The shortest side can be either one. I don't care which one you pick. I'm arbitrarily choosing number 2 here. Well, how much fabric is she going to need to use? So she's going to need to use 32 multiplied by the area of one triangle. The problem is we don't have that area. It's going to be 1/2 times the base, which we don't know, multiplied by the height. So multiplied by 2 eventually. We've got to figure out what that base is. To figure out that base, nice, easy Pythagorean theorem. I'm going to go ahead and call this guy x. So let's put an x right there, equals... and solve for x here. We got x squared. You know what? Let's just go right to the answer after this. So we got x squared plus 2 squared equals 5 squared. And therefore x is equal to the square root of 25 squared minus 2 squared. Oop, 25 squared. That's silly. 5 squared. I cannot write. And therefore x is equivalent to the square root of 21. Plug it right into our calculator. 1/2 times 2 is 1, so I don't have to do that. Just 32 times that rad 21. And we get 146.64. And looks like that is letter F. Done, done, done. Continuing on. Find the radius of a circle in which the circumference is 2 pi squared centimeters. So we know that circumference, using our formula sheet, is 2 pi r is equivalent to 2 pi squared. Now we can just divide both sides by 2 and divide both sides by pi. So if we divide both sides by 2, first I'm going to do that. So pi r equals pi squared. If we divide both sides by pi now, we're just going to get radius equals pi. And don't forget your units. I really should have put units in this one too, but it had it in the answer, so I kind of skimped out on units there. Area of the square whose perimeter is 52 miles. So remember a square, it says all of the sides add up to 52. We could put x here, all add up to 52, or more easily, just do 52 divided by 4. 52 divided by 4 is 13. And we're finding the area of that square, so that's one side length is x. So our answer here is 13 squared, which is 169 miles squared. Not too bad. Now it says here AC equals 30 and ABCD is 270. What is the length of DB? So unfortunately this question's kind of not doable unless they tell you it's a kite. However, I'm assuming it's a kite because it looks like a kite. You're not really allowed to do that in these questions, but if that happened on the test or quiz, you could always ask me. I'm definitely certain it's supposed to be a kite here. So it says AC is 30. And we know that the formula for a kite is 1/2 diagonal 1 times diagonal 2, and that's what we're looking for, that whole length BD. That's got to be 270. So 15x equals 270, and therefore x is equivalent to, oh boy, what's that, 18? Not too bad. So 18, and what are the units here? We got centimeters. Last question on this one. If the perimeter of a hexagon is 72 meters, what is the area? It really should have said regular hexagon, because the area could have been anything. So if the perimeter is 72, now we have one of these questions we really got to do all of the work for. So showing all of the work possible in this question. Remember, a hexagon has 6 sides, so there are 6 of these little triangles in this hexagon. I'm not going to draw the whole hexagon, but there's 1, 2, 3, 4, 5, 6 triangles in it, and therefore this whole side here is 60 degrees. And if I were to divide that in 2, I'd get 30 degrees. So as a reminder, what I did was I did 360 divided by 6, and that gave me 60 degrees, and that was the whole angle there. But then after that, I did 60 divided by 2, and that gave me 30 degrees, and that's where I got my little angle guy right there. Then this entire length there has to be 72 divided by 2. Sorry, 72 divided by 6. I don't know why I said divided by 2. That was wrong. 72 divided by 6. And again, the reason why is there are 6 of these triangles going around. 72 divided by 6 is 12. Now we divide by 2. 12 divided by 2 is 6. After that, we need to go ahead and find this height right here. Remember, that height is called the apothem or the apothem. The apothem here, we can go ahead and set up an equation. We can say that the tangent of 30 degrees is equivalent to 6 divided by the height. Again, if you need help with those tangent equations, which one's opposite adjacent, we got that formula sheet. Please use it. We have an opposite of 6 from the 30, an adjacent of height. So h equals 6 divided by that tan of 30. And you can plug this into the calculator now if you'd like to get a number of some kind. I mean, you'll get some strange little number here. Whatever 6 times the square root of 3 is what you're going to get. But it's not what we need right now. We want to go ahead and actually find this entire thing. As a reminder, the entire formula, which is again on your formula sheet, the area is 1/2 times the apothem, which is this number. So I'm just going to go ahead and put that in so I can plug it all into my calculator at the same time. If you wanted to do this without doing it all at the same time, that's fine. Just remember not to round until the very last step, if possible. Multiplied by the perimeter here. So 1/2 the apothem times the perimeter times 72. And finally, our area is therefore going to be equal to, let's go ahead and plug this bad boy in. We got 1 divided by 2 multiplied by, just to remind you guys, there's a way to put fractions into your calculator if you needed help, you couldn't remember where the parentheses are. You alpha, y equals enter. 6 divided by the tangent of 30 degrees multiplied by 72, and this ends up being 374 points, and it said nearest tenth somewhere, so 1 meters squared here. Nice. Now that we finished this page, we got our second shout out of the night, and this one goes out to my boy Tyler. He stays quiet a lot of time, but he asks some good questions, and he works very, very hard, and I'm definitely proud of him for all the effort that he puts into my class. So, awesome work, Tyler. Thank you so much. All right, going on to the next one. I said evens on this worksheet because we've actually already done all the other problems on this page if you were in my class. If you're in the other classes, whatever you got to do with the odds, something else, it's cool. So these questions, you got to just divide it up into shapes that you're able to deal with. So for instance, right here, I can divide this into a nice, neat little rectangle where this length is 3 here and this length is now 6. This length is still 10. So we have 2 different areas to add together. We have the area of this nice little rectangle, which is 3 times 10. And then you have the area of this trapezoid here, which is going to be 1/2 times 10 plus 14, multiplied by the height, which is 6, not 9. Be very careful with that. And our unit's going to be millimeters squared. What's this going to be? We got 30 plus 3 times 24, so 102 millimeters squared. You guys might want to check my work on all these, by the way. I'm doing these in my head, so if I get them wrong, I apologize. Now, you could also just do this. Instead of like doing all the equations up here, you could just be like, well, this little 6 times 2, this area right there is 12, and this little 8 times 3 there, this area is 24, and therefore the overall area is, adding them up, got to be 36 meters squared. There's another way to think about it. This one here, love this problem. Really, really like this problem. I hope this one's on the test. I don't actually remember if it is, but it's a cool problem. Because we got the 45 area is the whole big one. 9 times 5 is that whole area. Then you got to subtract the area of this thing. What is the area of that thing? Well, area of a circle is pi r squared. But we don't have a radius. We have a diameter. The diameter is 5. So the radius, half that length, must be 2.5. So the radius must be pi times 2.5 squared. And we got to make sure we plug all of this into the calculator. So 45 minus pi times 2.5 squared. And we get a nice little 25 points. And we're rounding that tenth again. Says so, tenth at the top of the page here. 25.4 centimeters squared. Nice. Anyways, let's continue on. The area of the white rectangle is 7 centimeters with the area of the shaded region. Well, I mean, that's easy, right? It's just 16, the area of the whole thing, minus the 7, which is 9 centimeters squared. Not too much. I don't really see what the words are on this question. I don't know what they're trying to say, but, you know, let's just do the problem. So doing this whole question here, I'm imagining it wants the shaded area because it like asked for shaded in the other ones. So I'm just going to do shaded area for all of these questions. So I know I'm only supposed to be doing every other question. So was I supposed to skip that problem? I literally don't even know. Odds. Let's just do the odds. We got 3, and then this must be 4 and 7. Man, I don't even know which problems I'm supposed to be doing. Like I should have just like circled them more. I apologize, guys. We've already done a problem like this, so I'm just going to do this one instead. You know, just divide this up. That's an easy question. Okay. Well, maybe it's not the easiest question. We know this area is 64, and then this length down here is going to be 4 plus 8 plus 3, which is 15. And so, therefore, 15 times 3 is 45. All right, easy enough. We finished the problem. I'm doing this problem, though, because I think it's important to know how to do. It's going to be the big, huge circle, the whole area, minus the smaller area. So that's going to be pi times 6 squared minus pi times 4 squared. So here, we're going to go ahead and do a cutesy little thing. We can actually just do 6 squared first, minus the 4 squared, like that, and then times pi. It'll give us the correct answer. And we got 62.8 inches squared. Which one do I want to do next? I don't want to do this one. It's going to take forever, so we can skip that guy. And nothing that hard in the test anyways. And it looks like these two are kind of similar in nature, but I like this one. It's like a basketball court. So find the area, the section of the basketball court shown. Round to the nearest tenth. Dang, look at that thing. I don't even know what area they want. They want the whole basketball court? Wouldn't the whole basketball court area? I know what they want us to do here. So first of all, everything's in feet, so we need to convert everything to feet. So 39 feet 6 inches. Well, 6 inches is half a foot, so that's going to be 39.5 feet. And 3 inches is a quarter of a foot, or 0.25 feet. So 5.25 feet. So the area of this rectangle right there has got to be these two numbers multiplied together. Let's use our calculator for that area of the rectangle. 39.5 multiplied by 5.25. And that's going to be, so this little area right there is 207.375. I'm not rounding to the last step. And then after that, the area of the rest of the thing is a half circle. So the area of the half circle, we have a diameter of 39.5. So 39.5 divided by 2 there is 19.75. So the area of this thing right here, which is this whole section there, that whole area is pi multiplied by 19.75 quantity squared. And I realize I just screwed up a previous problem. So I didn't divide by 2 in that previous question. What a disaster. This guy's divided by 2. It's only half a circle. This is not even the right answer. What a disaster that is. So 45 minus, and I got to retype this in now. We got pi times 2.5 squared divided by 2. This is the right answer now. 35.2 centimeters squared. I apologize for that one. Oh well. Moving on. Back to this guy. Finishing this question up. So we have, boom. Talking about it one more time. We're finding the area of this rectangle. Finding the area of the semicircle. In order to find those both, we had to convert these to feet first. We could have also converted to inches, but then we would have had to deal more work at the end. But we just have to add these two numbers up. So let's type all of this into the calculator at the same time. So we have this 207.375 plus pi times 19.75 squared divided by 2. And we get 820.1, which is right there, this guy. Not too big of a deal. I'm going to slow down. I feel like I sped up too much because I was like flipping back and forth. Calming down for a second. What's up, guys? Man, how much more problems do I have to do? This is going to be, man, look how much more work we have to do here. There's a lot of stuff. Oh well, life goes on. Let's do it. So we have done, how many problems have we done on this page? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 problems. And we've done 1, 2, 3, 4 problems. Just got to do one more. All right. I think I assigned this one as a homework question already. Yeah, we assigned this one. Find the actual area of the court to the nearest foot. This is estimate? I don't know what I want to estimate. Let's actually just do the whole thing. This is a unit 3 inches here. We're playing tetherball, or 3 feet, sorry, 6 foot diameter. And pi times 3 squared. Why is this even a question? We've like done this a million times already. 3 squared times pi. Boom. Okay, we got 28.3 feet squared. All right, let's move on to the next page. On to the next one. I think we did these problems too, to be honest. So I'm just going to do the evens because we kind of already did these questions somewhere. We just draw and classify and give in the vertices, find the perimeter and area, round to the nearest tenth if necessary. There is a question like this on the test. We got to make sure we know how to do these for sure. So let's make sure we can do them. Let's just do one of these. I'm only going to do one because I think we don't need to do all of them here. So we got negative 2 this way, and then 1, 2, 3 up this way. There's point A. And then B is 3, 1, so 1, 2, 3, 1. There's letter B. And then C is going to be negative 2, negative 1. There's C, and D is negative 3, 1. Up here is letter D. So looking at this guy, it's completely symmetrical on both sides here. Because it's completely symmetrical over this dotted line DB, this guy must be a kite. So because it has to be a kite, and that's because this length and this length and this length and this length are exactly the same, we can just go ahead and use the kite formula, which is 1/2 diagonal 1 times diagonal 2. Diagonal 1 has a length of 1, 2, 3, 4, 5, 6. Oh yeah, I wrote kite. So it's 1/2 times 6 times 1, 2, 3, 4. And that would be 12. Easy enough. Really not too much to it. It also said find the perimeter, though. So find the perimeter. This is area. Find the perimeter. Oh boy, it has a little bit more effort here. We got to do some Pythagorean Theorem on steroids here. So let's do some Pythagorean Theorem. You could do distance formula if you want, but honestly, drawing the picture and doing Pythagorean Theorem is probably easier for us to understand. So Pythagorean Theorem here with this distance here, we're finding this length x, and then this is also x, and then we'll find y, and that's also y. So we have x squared is going to be equal to, that length was just 1 squared, plus that length was 2 squared, so x is going to be the square root of 5. And then y here, we'd have y squared is got to be equal to, and then we got 2 squared, that same height, and then this was going to be 5 going across there. So therefore, y is equal to the square root of 29, and therefore our perimeter is going to be rad 5 plus rad 5 plus rad 29 plus rad 29, which is 2 times the square root of 5. You could have also just typed in more, plus 2 times the square root of 29. And that's going to give us 15.24, so 15.2 is our perimeter. A little bit of extra effort there, but do have to be able to do it. Let's finish up this packet. We're on to the last 2 pages now. The base of the parallelogram being multiplied by 3/4. If you're only multiplying by a base, the area also gets multiplied by 3/4. So area is multiplied by 3/4. Really not much to it. They just wanted you to describe what happens. So the length of the rectangle, 12 yards, and width 11, is divided by 6. So just the length divided by 6. So again, area is divided by 6. Not much to it. I'm just going to do every single one of these because I think it's important. So if base is doubled, again, area is doubled. So if you're only multiplying one length by a number, the area is just also multiplied by that length. Same thing with this one. Area is going to be multiplied by a third. I don't have to really say much about it. Let's go on to the next page. Hopefully we have one that's a little bit harder. Here we go. The length and width are both multiplied by 4/3. So if the length and width are both multiplied by 4/3, then the area is going to get multiplied by 4/3 squared, which is going to be 16 over 9. So the area is going to be multiplied by 16 over 9. So, whatever the original area was is going to be multiplied by that number. So, original area was 9 times 3, and the new area is going to be times 16 divided by 9. The new area is going to be 48. We could verify this if we really wanted to. Multiplying that by 4/3 is going to be 4. Multiplying that by 4/3 is going to be 12. And 4 times 12 is 48. Another way of thinking about it. But it also wants us to describe the change on the perimeter. The perimeter is also just multiplied by 4/3, not the square. So the square happens with area. You can think about this as like centimeters squared would be there. Actually, it's feet squared, isn't it? This is feet squared. So because that one's feet squared, it gets squared when the multiplying. But this guy, the perimeter, is just regular old feet, so it only gets multiplied once. So same idea. The base and height of a triangle are tripled. So if both of them are tripled means multiplied by 3. So the area is multiplied by 3 squared, or 9. But the perimeter is still only multiplied by 3. That is the key concept here. Area gets multiplied by the square of the multiplication, and the perimeter gets multiplied by the number itself. So be very careful with this guy. The radius, who cares what this is? It's just a circle. Circles, if you divide a radius by 2, you're actually dividing like this side by 2 and that side by 2 and all of them by 2. So because you're dividing all of them by 2, dividing by 2 is equivalent to multiplying by a half. So dividing by 2, but you're like doing it twice, so you're squaring it. So you end up being area is multiplied by 1/4. You could also think about it, area is divided by 4 instead, so you're dividing by 2 twice, so 2 squared is 4. Another way of thinking about it. Perimeter, though, we don't even call it perimeter, we call it circumference. Circumference going all the way around here is just going to be straight divided by 2. Same idea. If they're all multiplied by 1/8, then the overall area gets multiplied by 1 over 64. So again, if your area has been multiplied by 1 over 64, then going backwards, it's done by the square root. Anyways, so now let's think about what concept I just said. The rhombus has an area of 9. The area is multiplied by 5. Describe the effects on the diagonals. The diagonals are like the lengths of this rhombus here. So if both diagonals have gotten multiplied by 5, then the area would have been multiplied by 25. But that's not right. So the area instead here, so the area got multiplied by 5. That directly implies the diagonals got multiplied by the square root of 5. That's a key question right there at the end. I have like a whole page of the test talking about this concept, this whole page's concept. If the area is multiplied by a number, then the length had to be multiplied by the square root of the number. The square root of 16 over 9 is 4/3. The square root of 9 is 3. The circumference, The area is halved. Describe the effect. So if the area is halved, the square roots of a half is what happens to the circumference. Circumference gets multiplied by the square root of half. You can leave it like that in the test for all I care. I would give you full credit for that. That's really what I care about, is you notice that if you have an area, then the circumference gets multiplied by the square root of that area. Just a visual proof of this one more time. Let's say we had a square whose side lengths were, let's say the side lengths were 8 and 8. And now the area is therefore 64. Let's say I divided that area by, let's say we divided that area by, I don't know. Let's just divide the area by, let me think about it. Dividing the area by 2. Let's divide the area by 2. So if the area has been divided by 2, now both of these numbers must multiply together to get to 32. So 32 multiplied by what number, what number multiplied by itself squared is going to be equal to 32? That's going to be the square root of 32. So square root of 32, that's going to be this 5.65. That is the new side over here. This is rad 32 up here. 5.65. But how could I go from 8 to 5.65? If I multiply by the square root of a half, it'll work because I divided by 2. So 8 times the square root of 1/2. Sure enough, the same 5.65. That is the main concept I'm trying to get across here. That's the last page here. Thanks for watching the whole video. I know it was long. Good luck on that test on Thursday. You guys are awesome. Peace.